Hello everyone, welcome to my channel. In this video, I'll explain you one more example on finding transmission parameters for the circuit shown in figure. Transmission parameters are also called as ABCD parameters. Whenever a problem is given, first write the main equations. ABCD parameter equations are V1 equal to AV2 minus BI2, I1 equal to CV2 minus DI2. To find the value of A and C, I2 must be equal to 0. From the equations, from this equation, you can write A equal to V1 by V2 when I2 equal to 0. And here C equal to I1 divided by V2 when I2 equal to 0. In a similar way, to find B and D values, V2 should be equal to 0. B equal to minus V1 by I2 when V2 equal to 0. D equal to minus I1 by V2 when V2 equal to 0. Let us start finding each and every parameter. To find A and C, I'm just rewriting the things which we have written in the earlier slide. To find A and C, I2 equal to 0, A equal to V1 by V2, I2 equal to 0, C equal to I1 by V2 and I2 equal to 0. Let me redraw the figure. Two ohms, 2 ohms, 2 ohms. I1 and here this is V1, V2 and I2. This is the circuit given to us. To find the values of A and C, I2 should be equal to 0. So when I2 equal to 0, the circuit remains the same. So this is the circuit remains same and the voltage across 2 ohms is V2. Let us start finding the value of A. To find value of A, we need V1 and V2 values. To have V1 can be written as I1 into R equivalent. From the circuit, these two resistors are in series in parallel with this resistor because current gets divided at this node point. And I can write I1 equal to 2 plus 2. These two are in series in parallel with 2. Therefore, I1 into 2 into 4 by 2 plus 4. So 8 by 6. 4 by 3. V1 equal to I1 into 4 by 3. And we can write here V2 equal to 2 into I dash. So voltage across this 2 ohm resistors can be written as I dash. Current flowing into this, same current flows into this resistor as well. Current flowing into resistance value. Using current divider rule, we can write I dash equal to total current. Total current is I1 into opposite resistance 2 ohm divided by total resistance. Total is 2 plus 2 plus 2. 2 plus 2 plus 2. So I1 into 2 divided by 6. I1 into 1 divided by 3. By substituting this I dash value here, we can write V2 equal to 2I1 by 3. Therefore, A value can be written as V1 is from here 4 by 3 into I1 and V2 from here I can write 2 by 3 into I1. I1 gets cancelled, 3 gets cancelled. We can have the value of A value as 2. A is nothing but it is a voltage gain parameter. So A is a dimensionless quantity. To find the value of C, we should have I1 and V2. And here we got V2. So C can be written as I1 by, in place of V2, I'll substitute 2 by 3 I1. I1 gets cancelled. The value will be 3 by 2. That equal to 1.5 mho. Because C equal to, here we have I1 divided by V2, which is admittance. Units of admittance is mho. Value of C is 1.5 mho. Next, to find the values of B and D, V2 equal to 0, B equal to minus V1 by I2 when V2 equal to 0, and D equal to minus I1 by I2 when V2 equal to 0. I'll redraw the circuit now. Two ohms, 2 ohms, 2 ohm, I1, V1, I2, and this is V2. Here the condition is V2 equal to 0. So you have to short circuit these two terminals, V2 equal to 0. When you short circuit the terminals, resistance here is 0. So if you calculate equivalent resistance for these two, 0 into 2 by 0 plus 2, which is equal to 0 ohms. So we can just redraw the above circuit like I1, and this is V1, and here. From this circuit, we'll find out the values. To find the value of B, we should have V1 and I2 values. So from the circuit, I'll write V1 equal to I1 into R equivalent. R equivalent is here 2 ohms and 2 ohms are in parallel because current is getting divided in these two branches. So R equivalent equal to I1 2 parallel to 2. So I1 into 2 into 2 by 2 plus 2. So 4 by 4, which is equal to V1 equal to I1. Next, to find I2 here, I2 equal to minus I dash. Here current I1 gets divided in these two branches, and I'm assuming the current coming in this branch is I dash. And as I dash and I2 are in opposite direction, I2 is equal to minus I dash. According to current divider rule, I dash can be written as total current I1 into opposite branch resistance 2 divided by total resistance. Total is 2 plus 2, which is equal to I1 divided by 2. And I2 equal to minus I dash, which is equal to, okay. By substituting these two values at B equal to minus V1, that is minus I1, from here I am writing, and I2 as minus I1 by 2, minus I1 by 2. I1 gets cancelled, B value equal to 2. And it is V by I impedance, so units is 2 ohms. Coming to the value of D, D equal to minus I1 by I2, minus I1, and I2 can be substituted like this, minus I1 by 2, I1 gets cancelled, D equal to 2. D is a current gain parameter, so it is a dimensionless quantity. Finally, we have got the values of A, B, C, and D. A value as 2, C value as 1.5 mho, 1.5 mho, and B value and D value as 2, 2. B value as 2 ohms and D value as 2 ohms. You can write the final equations as V1 equal to AV2 minus BI2, I1 equal to CV2 minus DI2. This is how we can find the ABCD parameters for the circuit shown. That's all for this video. Thank you.